All right, my name is Mark and this is my unboxing channel.
I'm Andrey Phau. I'm a core developer in TON Foundation.
So you went hardcore from the beginning.
I need to improve gameplay experience for my players. So TON, it's not only about a blockchain or cryptocurrency. I think it's only a beginning.
Okay, so I use regular node as a gateway to validator nodes.
Yep. No encryption anymore.
Hello guys, my name is Mark and I'm super happy to have as a guest Andrey Phau.
Yeah.
So let's welcome him and I will shortly introduce him. This is one of the core developers on TON team and we will hear more about what exactly he does for TON. But let's first just start with asking him, how would you introduce yourself? So
yeah. I'm Andrey Phau. I'm a core developer in TON Foundation. So I'm developing some tools for developers on TON and some SDK for actually to developers who can interact with the blockchain.
Nice, nice. So we will talk about the details of SDK and the tools later. But something that would be very interesting to know for developers mostly, but also for anybody who is in TON, is what is your background? So where are you coming from? What's your education? How did you get into programming? If you can tell us a little bit, would be super nice.
It's a so funny way how I becoming a developer. So I start developing at 10 years old. When I have 10 years old, actually, I'm playing in computer games. I very love to play computer games.
Which one? Which one is your favorite?
My favorite, Minecraft. Minecraft.
Okay.
So I make game server. I have some people playing on it, and someone I need to improve gameplay experience for my players. And I starting dive into developing plugins for Minecraft.
And what language was that? I'd never programmed.
Java.
Java. So you went hardcore from the beginning.
So I think Java it's not a hard language. It's I think it's obviously my language for start developer way for teach programming. It's nice. Some language, and I still using Java sometimes. So
okay. Cool. And so basically you started programming the Minecraft server, and what is the way from your Minecraft server when you're 10 years old to one of the core developers in TON? So what's the path?
So I developing my server during 5 years. And I meet one person. His name is Roman, and he invited me to join his project on Minecraft. Roma is head of onboarding TON Foundation.
Okay, now I see the connection. Yes, we of course we had Roman on our channel. We interviewed him, and we had this experience, like when he explained us the experience that he was working with on the Minecraft as well. So it is cool. So, but where did you work, like in between these two projects? Like where did you work?
I'm working in Russian company named ArtGuard. It's software development with blocking ads. So its name is ArtGuard.
And what was your role? Or like, so I believe was that company working with Minecraft servers, or it was some other projects that you work on?
Other project when I have 18 years old, I'm thinking, so Minecraft is good, but it's not very profit, and I want to be an employment, which I have with good payment for my job. So I'm searching some company where I can, with my development experience, can fit it.
Like with Java, right? So
yes,
your Java was your main like stack that you were continuing with.
Yeah.
Okay, cool. And just to maybe connect it to the TON, so from your experience, how did it happen that your particular skill set that you were acquiring while working with this company, how does it brought you to TON? Is TON what in TON is written in Java? Like, what is the connection of your stack?
It's so interesting question because when I joined in ArtGuard, they development a new product named ArtGuard VPN.
Oh, okay.
And I'm working on VPN backend.
Nice. So basically, I believe let's like from VPN. That's the good place to move. Like what you're doing for TON.
So yeah, because when I come to TON Foundation, they hunted me from leaving ArtGuard for developing TON Proxy.
Nice. So now we are close to like, and I believe we are going to talk a lot about TON Proxy, but also I wanted to ask you a question before we switch to Proxy completely. First one is about TON. So did you find something special in TON itself, like in the idea of having this open network and being kind of like a child at the beginning, but in future it will be a bigger brother of Telegram. So TON is the cryptocurrency which is super scalable, super fast, and it's connected to Telegram that has a lot of users. Like, what are your thoughts on TON? Like, are you passionate about like what you like in TON? You know.
So TON, it's not only about blockchain or cryptocurrency. It's about technology. It has very cool technologies which can use not in crypto but in regular projects. Regular businesses can use TON technologies for its own purpose.
Can you give us some examples? Like
some example is very cool peer-to-peer ADNL protocol for communication with two different computers. It's like a quick protocol which can transfer some data packets, but it's not centralized and like Quick, because Quick uses certificates as TLS. So it's very centralized because for getting the TLS certificate you need it buy or claim it from a big company like Cloudflare and others.
So basically, we're coming that if there's a company who wants to have a fast and secure data transferring like medium, they could use TON for that.
Yes, and they can use a private keys for encryption, not certificates.
Okay, but how would it look like if we have TON now, like nodes, we have the protocol itself, like what would they need to do in order to transfer that?
So I'm developing SDK for TON, and my SDK is have different separate modules which can use separately from TON. So you can use ADNL module in your project and don't know about TON itself.
Ah, okay. Is it already out? Like, is it live?
Yes, it's
so it can be
open source. It's open source. Some companies use already it.
Okay, so maybe are we already in the topic of proxy, or like is it already TON proxy or not yet? because I really want us to understand. So we've heard TON Proxy. Everything I know about TON Proxy is that it allows me to route traffic in a way. So I can I can set the proxy of TON, and whatever I'm opening in my phone, it will not be under control of the internet provider.
I basically all data transfer in using Arduino protocol is highly encrypted, and it's now has some headers in pockets. It's fully encrypted. Quicker has some headers that is can identify like it's quick protocol or TLS encryption used, but for providers and other third person who can look in traffic, he can't determine that it's actually a denial. It's can only see on some random bytes in pockets.
Okay, I see. I think I understand that. We are not like TON proxy is just a way of using ADNL protocol, right? Yeah. So basically, we could use ADNL protocol on itself without using TON proxy. TON proxy is kind of like a user product.
It's a user product that's highly integrated with TON. TON nodes, which using for calculations in validators, are using Arduino protocol for communications.
Okay. Oh, that's cool. So basically, but then we already talked about two examples of using Arduino, like TON proxy, and also you said, this is very interesting, that you said that any business could already use now the ADNL to avoid centralized certificate issuers, right? Yeah. So if we have a whiteboard here, maybe it would be a cool example to kind of show how exactly it can happen, because I don't quite understand. So we have, let's say we have TON nodes. We have TON nodes that are running, let's say, consensus. So we are not going into how exactly the network can be, let's say, trustless. We're not going into this deep, but so here we have some person A, person B, and some company, let's say, I don't know, like any name, company Cat, company called Cat. They want to, like person A is in the office, person B is also in the office, and they want to create a way that person A can have access to all the files of person B, so to download all the files from his computer, and person B wants to download any files from person A computer. So how does it happen because for cryptocurrency, I understand there is a consensus between nodes, and like from what you already said, the consensus, like for consensus, you need to like exchange data, and the nodes are exchanging data via ADNL, right? So this is where we kind of like understand the protocol. So but when a person wants to send some file like PDF, we understand that we need to create some software. So we create some app that is actually, this person is able to put the file here. And there is some app that this person is able to get the file. So how does it happen with nodes?
So any person have a private key. Yeah. Private key. They only knows your own private key. Names it's like PK. Okay.
Okay.
PK. With private key, you can calculate a public key.
Yes.
Public key. Name says pub key. And for create a communication with one person to person, they know it's both public keys. So in some way they exchange the public key. It's no matter how they have a public key.
Yeah.
So then public key is hashed by SHA-2056.
Okay.
And this is ordinal address.
Okay.
Ordinal address. And so on here too. And then they also know its own IP address. So they also have IP address. So one thing they need to know is ordinal address of another people who, and they know some maybe one DHT node. I'm talking about later what is a DHT node. So maybe it's some DHT node. What is a DHT node? It's like a global table with ordinal address. It's key value pair.
Okay.
It's a big table with a key value pair. Ordinal address to IP address.
Nice.
And so it's a very awesome feature because you can dynamically change IP address.
Okay.
Like you have a mobile phone, you're sitting in home using a Wi-Fi, and then you can leave your home and connect to LTE connection in mobile, and your IP address is changed.
Yeah.
But original address not changed because it's a hash of public key.
Yeah, true.
Is so. And
this is like DNS. Just to
like
compare to what it is,
DNS,
it's like DNS in real internet, but yeah, similar type.
It's similar, awesome. And any person can identify each other with ordinal address.
Okay.
So it's ordinal is abstract datagram network layer.
Nice.
It's a network layer behind IP. So, and this person is tell to DHT node that ordinal address equals some IP address, and he using a signature. He is using signature for calculates from private key for proof. It says I am actually owner of this address.
ADNL address, yeah.
Because someone can tell no, I'm the owner, but he don't know actually private key that calculates to public key that is hashed by SHA to ADNL.
Okay.
It gives some trust for this is actually owner of its address, and he is public it to DHT node.
Okay.
And then DHT nodes are broadcasting about this address. If one node knows it has a new ordinal address, they broadcasting to others. And all network knows about this ordinal address is directing to some IP address.
Cool. So basically, if I understood right, if I connect with, how do I connect it there? Like, let's say I have a DNL address. Maybe let's go deeper here. So we were talking that this person just has a private key, and he has public key. He's doing with the encoding SHA-256. He gets his ADNL address, and he has his IP address. So once this user is connecting to the to this network, or how does it? What is the connection? When does he start? When does he tells the node that this IP address, that this is his
At
IP
beginning,
address?
at beginning, when he initialized this app, he is told to DHT that he has this address.
Okay, so basically, he has to. So if to go into like normal people don't know what is the process that happens under the app. So basically, he opens the app, he authorizes with private key. Okay, he already.
So private key can be used by generating by seed phrases like encrypt, or if you want to be anonymous, you can generate private key every session when you initializing this app.
Okay. So
it's no matter. It's more secure is generating every session your private key.
Okay. So basically, if you want it completely anonymous, then yes, every time you open the app, you would generate a private key and you would connect user to this network broadcasting his IP. If this is some app that needs user authentication, basically this app can show QR code. He can scan this QR code with TON Hub and sign, like prove the owner, like, because his private key is on his TON Hub. Like in this case, his private key is on his TON Hub, and he's going to sign a transaction, or somehow he needs to prove that, like scanning this QR code, he's proving this DNS.
It's automatic. It's not. User don't know about. Don't know about this process. It's automatic. He don't know to scan. It's automatic process when.
Okay, I understand. So basically,
in the application, just generating private key, calculates public key, and publish a hash of denial address to DHT node. It takes less than 1 second. When you just open the app, it's automatic process to.
Okay, but I just want to understand if he has, so he has 2 devices, and he wants to connect to this network from both devices. He would need to have private key on both devices, right?
Yeah.
So okay,
every device has its own private key. But it's a private key not identifies as person, it identifies as a device.
Okay, this makes complete sense. So we just get away from TON Hub. This has nothing to do with wallets and stuff.
Yeah.
This is just identification.
As I said, this can use separately from blockchain technology.
Yeah, this is cool. So it was just me. I'm asking stupid questions sometimes because I don't understand things, and this is cool that you can kind of like help me to do that, and as well to our viewers who are viewing that. So cool. We understand that this is define a device. Device is getting the ADNL address and claiming that this is his IP address, and he is connected to the network. It's broadcasted on all the DHT nodes. Just to confirm, is this the same nodes that, what DHT stands for?
Distributed hash table.
Okay. Is it?
Or decentralized, it's is array of some servers. You need to know only one address for DHT, and the other DHTs know about other. So
okay, and how is this different from the validator nodes? So we have blockchain with validator nodes?
In TON, DHT node also is a validator.
Okay.
It's protocol can use also both as a DHT, as a validator, as another thing.
Awesome, I understand. So basically, when I send a transaction from, like if I want to send you like 1 TON now, I would use the same nodes, but it would be a whole different set of actions. Like I would have to sign a transaction, send it to one of the nodes, then it would be proved for consensus.
It's another layer.
This is whole another layer. Yeah, that's what I wanted to point out.
The stack, it's something is IP, IP, TCP, UDP.
Okay.
Then is ADNL layer, abstract datagram network layer.
Okay.
Is that's used for encryption, for communicating with other computers, nodes, devices, people. Is no matter. And on these layers is application layer. So in the case of TON, this application layer is TON.
Okay.
So on this layer we're using is business logic about sending transactions, blockchain, and another things.
Okay.
DNL is on different layer.
Okay.
It's like it's can use like regular TCP. It's like a legacy TCP. So you can, when you want to send some data to another server from client, you're using a TCP protocol. But it's a DNL protocol has bundled encryption and routing via DNL address.
Okay. Yeah. Cool. I think I understand now. And so this what we just described, we described the ADNL protocol, how it is actually becoming a layer, yeah?
For now, I'm just described how they can know how connect.
Okay.
But interesting thing is how encryption works. So TON and ADNL uses some cryptographic case named AD255.
Wow.
It's why not a RSA case like in SSH or something other? The main feature of AD25519 is it can use for signing, for proof that
Yes.
some owner owned some information. Verification signing, but as many cryptographic cases, they can't be used for actually encrypt data. But main feature is AD25519 is it can convert to X255 case. So this case can be used for calculation as shared key by using a key pair. It uses a Diffie-Hellman algorithm.
Okay.
So how it works? We have Alice.
So just to remind, we flipped the board, and we wanted to talk about the encryption. So if you could please write again the types of encryptions that we're talking about, and repeat why we need to why this is important. Like we had this network, we explained how other users can identify that this user is really with this IP address. So now why this is important?
Because AD 25519 can convert to some different type of key named X25519, and this case can used to be calculate some shared key. How it works? We have Alice and we have Bob. Mm-hmm. They have a private key and public key.
Okay.
And Bob also has a private key and public key. So they communicate about each other public keys. So it can send on an encrypted transfer protocol in an open way. So Alice says, I have this key, to Bob,
Public key.
public key, names is public key A. And Bob sends to Alice public Bob. So they now know each other public keys. And after that, the main feature that we can calculate a shared key for using for encryption. Shared key is calculates like pk a times public. So case is just a number. It's very huge long number. So it's just a mathematical operation that can calculate public B. And we have some number. 2, 5, 1, and so on. It is a shared key. Why its named shared key? Because when Bob do the same operation but with his private key and Alice public, he can equal. It's have the same key. So this key not transfer in network. It's very cool. Here they can calculate both keys and get a shared key.
One moment, I'd like to specify that the thing is a private key Alice times public key Bob equals the same stuff. It will be the same stuff as private key Bob times.
No. Yep.
It's different. It's same number will be like 2, 5, 18. Yeah, it's the same.
It's same. It's same.
Because they have different private keys.
Yep.
Was generated.
It's main feature of X25519 algorithm.
I understood this thing. I didn't understand like algorithm. Algorithm gives us the encryption way. So basically,
we can use this key for just a regular encryption like RES. Its names are asymmetric encryption. It's just a way how to calculate a shared key without transferring actual shared key by network.
This is cool. We understood how we can get a shared key, and we understood that this shared key is like calculated twice, once on the Alice app computer, and it also is calculated once on the Bob's computer. And this shared key must equal. To get the shared key, we have this encryption.
No, it's just a way to get a key for encryption. We can use another.
This way we get the key for the encryption.
And then we initialize IS encryption. With this shared key.
I can't believe this is the way from the Minecraft you get to this thing. This is unbelievable, guys. So and here we get the IS encryption. Are we already kind of like getting to this case? So should we get back? So now let's just remember that we got the keys for the encryption. We don't do any encryption yet. And we will need the encryption when we want to transfer something.
So we initialize encryption, and then we can encrypt all other data after transferring keys using this encryption.
So we move back here. Now we have keys for encryption. This is Alice, that is Bob, right? So basically, Alice and Bob want to, they need to pass some data. So this one opens the app and he wants to access this file that is on his computer. and other way around. So for this, they calculate the shared key. This happens under the hood. No one, they don't see it. It's just calculated once they connected it. At this point, they are ready to initiate the encryption of the file that they want to access, right?
Not on file. It's used to encrypt datagrams, which is transferred via network.
Okay.
And then, for example, Alice encrypts stream of datagrams.
What is datagrams?
Datagrams, it's a packet that has a fixed size.
Okay. Okay. So
some file, we have a file.
Okay.
File, for example, 2 gigabytes. So it breaks in some parts, little parts, around 1000 bytes.
Okay.
It's a standard for transferring datagrams using UDP protocol. So ADNL works above of UDP. So it's max size for datagrams using UDP protocol. So and then they encrypt just this little parts, sending via. Alice ask DHT node for getting IP address by ADNL address, asking Bob his public key, Bob asking Alice public key, they calculate a shared key for encryption, and then Alice sending data using this encryption. And so Bob getting encrypted packets, decrypt using shared key, and so on. Bob have some data.
Okay, super. And this we call.
This is ADNL protocol.
This is ADNL protocol. Nice. All right. And how do we get from this example to proxy?
So
TON proxy? Is it the
few hours more? We need to discuss more things.
Yeah, because if I understood right, proxy allows when I want to read some website.
So website is just an array of files that's shown.
So we can say this is website. It's not Bob. Does it work the same?
Yep. It's not a person. Can be. It's can be some web server. Names Bob server.
Okay. Okay.
And Alice when open app with browser. I ask app to download some files like HTML file. So they ask via DNL to get some files. They encrypt it, transferring, and then decrypt it and loads into browser.
And no one except Alice can open this file because no one can decrypt and open it. Cool. And basically no one knows which file and from where she asked.
Yep.
This is cool.
So TON proxy can also not using just one pair of communication. They can use some many nodes that they don't know about transferring some data. They can have onion tunneling, like in Tor.
Like in Tor. Okay, now because I've heard that there is some similar parts to Tor, and this is like we can have something like node C or whatever you want.
Let's draw it here.
Okay.
We have Alice. We have Bob. It's endpoints.
Okay, endpoints, yeah, not nodes.
And here we have some C.
Okay.
For now, Alice initialize connection with C via ADNL, and then C can make a communication with B. So B only see seen.
Okay, so B only knows the ADNL address of C.
Yep. And C is just a retransfer, like a proxy to Alice.
Nice. Nice.
That's how TON proxy works.
And this can be anything. It can be a website files. It can be a audio call. So it happens. It's happened fast. All right. If I understand right, you are doing the SDK to work with that. So where did we finish? We finished at the moment that
No, we are talking about A, B, C.
okay, so this is proxy. Now we understand how proxying works. I have a question. This application has to have, it can be written in JavaScript, it can be written in Go, it can be Node.js for server, it can be any language. And this SDK is enabling developer, some developer is coming up with a business logic. He wants to write a business logic. He wants to define like forms, and he defines which files should be transferred between them, for example. Or maybe it's a messenger, or maybe it's like phone call or something. But which languages is SDK ready for already?
It's ready on Kotlin and Golang.
Kotlin and Golang. So if you build your app with Kotlin, you would be able to already connect straight to the DHT node to understand the ADN.
DHT node, it's just node who contains ADNL address. It's not full.
Okay, so you could connect straight into the ADNL layer.
Yep.
You could, like SDK. So basically for you, this is just for your understanding, but from your workflow point of view, you would just need to come up with business logic, then get the SDK that is ready, like Kotlin, for example, and you would just kind of connect to ADNL layer, and that's it. So then you build your logic all around being able to transfer any data, any amount of data, being proxied, being encrypted, so only only the owners of the private keys would be able to kind of consume this data, to decrypt it and consume. Okay, but I want to ask another thing. This SDK, does it has to do something with light node? Because I wanted to understand that when light node is
light node about TON?
Yes, TON's light node. Like light node of TON, it happens on the application layer, right?
Yep.
So, all right. So these applications, there is nothing else we need but the SDK. So just wanted to get this clear. Okay, cool. Then I'm thinking which direction we can go. So there is something interesting that I wanted to know, the TON storage, because TON storage, so if this is TON proxy, I have a question back to TON proxy. So how I use it in Telegram, for example, I put proxy. So basically in Telegram, when there is no proxy, I from Telegram app, I access the servers of Telegram, and these servers can be blocked inside of country, for example, right? So I will not be able to send or receive messages, and therefore I go and put some URL of the proxy server, right? So how does it work? Like let's say if Telegram is blocked in the country, I would have to put the proxy server, and which.
So for example, let's
do you mind? Yeah. Okay.
let's say A is you.
Yeah.
C is proxy.
Proxy server.
Proxy. B is also third-party service or web server or something else. Just IP server. Not ADNL node, not a TON node. It's just a regular IP server. It can accept TCP or UDP or traffic. So you can just transfer all your traffic using TCP, UDP encrypted via ADNL, via proxy. And then proxy connects to regular IP server and transfer your data like you just regular connect directly. So
how does it happen for Telegram, for example? So
for example, you can stay in another country that can block to B server, and if you can access to proxy server in some different country or another region where IP server is available, you can just retransfer your all traffic from your device via proxy.
wow. So basically, if I connect this in Telegram, that
It works like a regular VPN. It's like a regular VPN.
all right, but here you connect via ADNL, and that's
Yep.
why country cannot block this, because you cannot block this. You don't know what to block, right? You have to turn off internet.
So, as I showed before, for initialization of a DNL session, you only send a public case which with another endpoint, for example, proxy. What is public key? Public key, it's just 256 bits of random data. So governments or internet providers can't determine what is it. It's just they can only see only you and another opponent knows it's a public key. But governments or internet providers don't know about this.
So they cannot block it. They would have to turn off internet. Yes.
They just see it's a random data. They can't block a random data, because if they want to block some random data, it can break some another applications.
Yeah.
Which they don't know about the protocols. It can be another application.
They can even break their own applications. So I will remove this part, because we don't need this anymore. This is proxy. We get back to that. This is proxy. We understood that. We understood how Telegram, for example, if I want to route all my traffic from Telegram app, I would put it inside of Telegram. I would put the proxy server, and it would work. Okay, but something that comes to my mind now is the TON DNS and TON storage, because we understood how, with the help of ADNL, we are organizing the proxy, proxy channels. But this is use case between two applications, and how does it come to the domain name server? So TON announced the DNS, and on which layer it is. So from what we have here, how do we get to the domain name server? Because if I understand right, this can be a website, this can be a user who is accessing the website. So, and he puts the mark.ton.
So it's on application layer. So TON DNS. So addresses with key value like mark.ton is storage not on DHT node. It's storage on a smart contract that controls your ownership
Okay. So, but smart contract. So it is stored on smart contract. Smart contract is run on TVM, and just maybe it's a random question, but where's TVM in this? Is it?
TVM is a TON virtual machine.
Yeah. Where is it?
It's an environment where some code works in. Code of smart contract can work and do something.
Yeah. But where is
it's
the?
like a JVM, Java Virtual Machine. Do you know JVM?
Yeah. But, I mean, and I also know TVM, so I'm programming some smart contracts as well. But where is it? Because I know that I just don't understand in this picture where is it run? Is it run inside of this node?
You can run a TVM in a light node on your application. It's initialized TVM, some code works, makes some output.
Okay.
And from this output, you get
you contribute to the consensus. So then you send the results into this node, right?
No.
Okay.
Look, when you need to resolve a TON DNS address, for example, mark.ton. So, what do? You connect to some nodes, TON nodes, not DHT, TON nodes, which stored blockchain.
Okay, so TON nodes is different from DHT nodes.
Yep.
Okay, and validator nodes, but I think you said that validator node.
Validator, it's also TON node, but he has stake and ability to generate new blocks.
Okay.
It's equals, but validators just generating new blocks and makes consensus for block will be valid.
Okay.
But you can connect another node without stake that's just get information from broadcasting from actual validators.
Okay, I'm sorry for stopping you on before you wanted to explain me how domain works, because domain, as you said, the domain is resolving on the level of TON application. So, but I don't see a connection between ADNL level that we just discussed and the TON application level. So maybe, if you don't mind, you could explain us this hierarchy of nodes, like which are who is nominator, who is validator. Is it possible? Can you do brief explanation? So where DHT node stands in this equation. But the main goal is to understand the ADNL layer, how it is interacting with the application layer.
Okay.
Let me clean this one because we don't need this encryption anymore. So we want to know all kinds of nodes that exist in TON. Maybe this is a question where we will understand how TON works, out of which component, like node example.
So we have an ADNL layer. Mm-hmm. ADNL layer is separate to TON layer. Mm-hmm. So we have just a DHT node, which is used only for ADNL communication and routing using ADNL address resolved with IP address.
Yeah.
It's a DHT node. It's just a big table with key value pair ADNL address equals IP address.
Okay.
It's first node.
Yeah.
Using in ADNL. And after this layer, we join to TON layer. It's what is showed is application layer. Mm-hmm. So we're thinking about TON as application. Mm-hmm. So TON has not a big amount of nodes. So we have just two nodes on TON. It says regular node and we have a validator node. is one difference with regular and validator is that validator can generate new blocks. Regular, because they don't have any stake, they don't generate new blocks.
What do? They broadcast data?
Yes, validator broadcasts data.
And regular, why do we need it?
Regular can just used for communication for decentralized apps.
Okay, so basically regular node is like read-only mode?
Yep.
So this is read-only, this is read and write?
Yep.
Okay.
Read plus write, regular just read only.
Okay.
So we have also a third type of node. It's named archive node. This node contains all history of a blockchain. So regular nodes have blockchain history about 1 month, plus minus. It takes 20 gigabytes of data. But archive node have all history of blockchain. It's about 2 terabytes of data
at the moment. And
at this moment.
Okay.
Plus minus, I don't know exactly, but it's plus minus 2 terabytes. It's also read-only. So you can ask from, but archive nodes have a little amount of online nodes, and if you want to just a regular asking some information from blockchain, you need to use regular nodes, because archive node can be very loaded.
Okay.
About requests. So regular, you need to use a regular node, but if you need to get information from past, you need to use archive node, because some blocks can be not stored in a regular mode. So.
Okay, and I've heard some word like nominator.
Nominator, it's not implemented yet. Nominator, it's node which can generate new blocks and asking validator to add this block and get a small part of reward from staking.
Okay.
But for now, it's not implemented.
Okay.
For now, validator node, it's also is nominator, but it's working in one application.
Cool.
In future, nominator will be a separate node, but for now, validator it equals nominator, because its logic do the same. So in the application layer of validator, nominator generates and retransfer in another module of this application to validator. That's proof that the block is right, and publish new block.
Okay. Cool. So we have 3 kinds of nodes on the application layer and 1 kind of node on the
DNS layer.
On the DNS layer. Can I maybe... So, just about a few business cases.
So, maybe its application layer can be separated by its TON layer, maybe.
Okay.
Because we...
application is then on TON. Yeah, okay.
Because this is logic about the blockchain.
Okay.
Actually.
Let's say TON.
TON. And then you, on application layer, your application.
Yeah. Okay.
Business logic.
So, if I understand right, light client as we discussed, it is interacting with the validator node.
Regular node.
With regular node. So light client we need for reading the data because regular node is read-only. And once we sign a once we sign a transaction, it is...
I understand your question.
Yeah.
You think it's read-only, but if you sign your transaction, regular node can send its validator node for approve.
Okay. So I use regular node as a gateway to validator nodes.
Yep.
Okay. So let's put like.
So it's a good if we changed it gateway node.
Gateway.
Yep.
Okay. Gateway, and this is archive. Archive would be like here. No one is pretty much using them. Archive, okay.
It's gateway. It's also known as, in TON terminology, is light server.
Light server. Okay. So if I understand it right, smart contracts are run on light client on any machine, and then the results are, we're not going to deep what are the results, but the smart contract is run basically on your machine, and you just submit your whatever was the result of your run of the smart contract, you submit it to the light server.
So smart contracts can also run in two modes, as read only and read and write.
Okay.
Read and write works on a validator node only.
Okay.
Because they generate blocks, and the blocks transactions is not just sending money. In TON, transactions is different states of smart contract. It's because when we write something in smart contract, it's changed the state.
Yes.
And then it makes a transaction, and then it writes in block.
Okay, let me fix it. Now we get back to the mark.ton. So mark.ton is representing a website. It is representing a website that is stored somewhere here on the machine. It has IP address, then it has ADNL address, and it can be accessed across the ADNL network, right? So once user hits mark.ton, what happens then?
Then your application asking gateway node.
Gateway node, okay.
To download last smart contract state.
Okay.
In smart contract state has some code.
Okay.
Then then application initialized a TVM locally.
Yeah.
TVM, and then TVM runs this code as input mark.ton. So mark.ton as input data to smart contract. And then smart contract, when it runs, its result output is ADNL address.
Okay. And then my application, it all happens, so the users would see this flow. Basically, I will just try to summarize, tell me if I'm wrong. So this is smart contract. So basically, we download the latest state, which has code. On the TVM machine, we are running it against mark.ton. Is it like one single smart contract for everyone?
No, it's have a hierarchy. With separate domain layers.
Okay.
So you can site.mark.ton. So for at beginning, you asking a main smart contract of domains. It's a .ton. All knowns about address of smart contract .ton.
Yes.
It's hard-coded in an application.
Okay.
Then you ask smart contract .ton to resolve mark address. Then mark address. So you get in smart contract start at two types of addresses. First type is actually as a result a denial address. Or second type of address is resolver address. Resolver address is can interpret as another smart contract that can be processed as resolving a next layer of a domain. So when you ask .ton, you firstly go to TON smart contract, .ton smart contract, then he resolves .mark. .mark can redirect to another smart contract.
Okay.
And then when he redirected to site smart contract, he can resolve it to a denial address.
Okay.
And then by using a denial address via a denial network, you can download some files for browser.
Wow. Wow.
But I have a question in terms of smart contract code. So application on your mobile, so it's like light client, will download smart contract code from
Gateway node.
Okay. And gateway node have the smart contract inside it stored?
It's like a gateway. He can ask another nodes if he don't start currently exactly this part of the block. He can broadcast to asking which node has this data, and another node retransfer to your gateway, and your gateway retransfer to your application this block.
Okay, yeah.
This is cool.
I understand.
I think we are not going to jump into TON storage. From what I understand from you, TON storage is using just the same ADNL to like jump around the apps, to pass data around the apps.
It's TON storage. It's likely about DNS how works. It asks so what is the file? File identifies by something address. Regular it's a hash of file. So TON storage application asks some hash to a main smart contract. Main smart contract redirects to another smart contract that can resolve which members of network has this file.
And which members means like which ADNL addresses have this file?
Yes.
Okay. Wow. This is awesome. This is so great to understand when you design and architect the app. So I was asking you questions. I was trying to understand. Maybe I will get more questions, and maybe we'll have to record another video with. Maybe we'll have to record another video with those questions. And please, now you will probably see at the top. You will see if this video is already out, the second one, or you will see it in description. So please check the description, and of course subscribe to the Telegram channel that you will find in description, because there's a place where all this cool stuff is going to be published. I'm just thinking maybe I'm missing something. Is there something super interesting that I'm missing, but you know, like about what you told us?
So I think it's only a beginning. Maybe a little bit later. Some another questions you can ask.
Okay.
In another video, maybe. For now, I think it's all.
Maybe last question, sorry to interrupt. But in terms of TON coin, like native currency of this entire system, those coins like use for transaction fees.
Yeah.
And transaction fees are only taken when you write something in the.
Yes. On read only case you don't pay a fee because you run this code on your application, and you don't pay a fee.
Okay. So yeah.
But I also got a question. It's back to nodes. Can I run a DHT node?
Yes, you can make just a light DHT node on your application, and then some another members of your network can ask you about if you know some of address.
But this is why we are decentralized.
It's can work as a mashup network.
Like which network?
Mashup.
Mashup? What is mashup?
Это надо.
Tested network.
Это надо на Википедии лучше посмотреть.
Okay, guys, I will leave a link on the Wikipedia. What is mashup? But what I was heading to, like question of Vlad about the fees. I was trying to understand if DHT nodes are getting rewarded in any way. That. But what I was heading to, like question of Vlad about the fees. I was trying to understand if DHT nodes are getting rewarded in any way that they are storing this valuable information.
So it's works. DHT node not store all of data. So when you ask some ADNL address, it's look at a beginning of address. Some, for example, your address contains 1, 0, no.
I will remove some stuff we already.
So it's sick on beginning of address. So he can find some node which can store this range of addresses.
Okay.
If node don't know, this node can tell you about neighbor of who can store this address.
But I just want to understand who is running these DHT nodes now. Is it Telegram?
For now, it runs on validators, on gateways. It's like for now it's in one massive application.
Okay, so basically, if I want to run a validator now, I will be like under the hood. I will be also DHT node holder.
Yep.
Okay, cool. But we want to kind of separate them because this is different layers.
Yep. For now, it's just in a monolith application, but it can be a separate application.
Okay, now it makes sense for me. And the only like the let's say we reward those participants of the network who are writing the right information into the blockchain. So validator nodes, we reward validator nodes, but together with that, they are also providing the hosting for this DHT information, ADNL to IP. So it's like a smaller part of the application, right? Cool. This makes sense. Man, I think we covered so much stuff. I so much thank you guys that you watched this thing all the way until this moment. If you did so, please reward yourself with something. We say very, very warm thank you for watching that. And we say even more warm thank you to Andrew. Man, I admire that you spend so much time with us. Thank you so much. Thank you for writing this SDKs of interacting with ADNL. Now we know exactly what he does. Like, we talked with him and we understand what is going on. And we're looking forward for next videos with you. I believe you will be one of the favorite guys on this channel. You're always welcome. This is super cool. And we're looking forward for TON storage. This will be cool stuff. Guys, see you again soon on the channel that you're now on. Thank you, Andrey.